Hello friends, welcome to my YouTube channel Dark Study. Friends, if you haven't subscribed my channel, then subscribe it now. Friends, our today's topic is nucleus. So what do you mean by nucleus? It is defined as a positively charged body inside the atom which contains protons and neutrons are called nucleus. Nucleus was first discovered by Rutherford when he struck a thin gold foil by alpha particles. He noticed that maximum alpha particles passed the gold foil without deflection, but only some alpha particles suffered deviation or struck back or made change in their path. As alpha particle was positively charged, so they suggested that positive charges are there in atom but are in very small volume, which they called nucleus. In this chapter, we shall learn more about nucleus. Our next topic is properties of nucleus. The things present inside the nucleus are called nuclear constituent. We all know a nucleus is made up of proton and neutrons. Nucleus is positively charged because of protons, as the neutron is chargeless. Mass of neutron is slightly greater than that of proton. The mass of proton and nucleus are mass of proton 1.67262231 into 10 to the power minus 27 kg and mass of neutron 1.674928 into 10 to the power minus 27 kg. The energy of physics is represented by E is equal to mc square. This famous theory is given by Albert Einstein. If we know the mass, then we can find energy, as c is speed of light in vacuum and its value is 3 into 10 to the power 8 meter per second. For example, mass of electron is me, that's equal to 9.109387 into 10 to the power minus 31 kg, and the equivalent energy will be mc square is equal to 510.99 keV. Here keV is kilo electron volt, and when 1 electron volt is changed into joule, then its value is 1 eV is equal to 1.602 into 10 to the power minus 19 joule. Thus mass of electron is 510 into 99 keV square. Similarly, we can find the mass of protons and neutrons. Mass of neutron is 993.56563 MeV c to the power minus 2, and the mass of proton is 938.27231 MeV c to the power minus square. The energy corresponding to the mass of a particle when it is at rest is called its rest mass energy. The another unit to describe mass in nuclear physics is unified atomic mass unit, and it is denoted by symbol U. 1 U value is defined as 1/12 of the mass of neutral carbon atom in its lowest energy state, which has 6 proton, 6 neutron and 6 electron. As you can see, friends, value of 1 U is equal to 1.660540 into 10 to the power minus 27 kg, and in energy form 1 U mass is 931.478 MeV c to the power minus 2. According to physics world, no two protons or two neutrons can have the same quantum state, but one proton and one neutron can exist in the same quantum state. Friends, when we want to calculate number of nucleus or other things, we don't always write proton plus neutron. Instead, we use some letters to denote the formula, as number of protons is denoted by Z, number of neutrons by N. So, when we find number of nucleus, we write Z plus N, and total number of nucleus is denoted by A. Also, total number of nucleus is also called mass number of the nucleus. Now we can symbolize an element when proton and mass number are known. We write X at superscript A and at subscript Z on the left hand side of X, where X is chemical symbol of element, A is mass number, and Z is number of proton. Thus, we can represent helium as H4 and 2, where 4 is mass number and 2 is number of protons. From these two, we can find the numbers of neutron, and that is A minus Z, or that's equal to 4 minus 2, and that is 2 neutrons. Similarly, U 238 by 92 represents a uranium nucleus containing 92 protons and 146 neutrons. We know number of protons Z is equal to the numbers of electrons. Therefore, the chemical properties of an element are also determined by number of protons Z. When two nuclei contains the same number of protons but a different number of neutrons, they are called isotopes. And when different nuclei has same number of neutrons but a different number of protons, they are called isotones. And if two or more nuclei contains same mass number but different protons number, they are called isobars. So friends, our next topic is nuclear stability, which means does nucleon can move freely here and there, or they decay easily with time. According to scientists, more than 1,000 nucleids have been identified, but many of them are not stable. An unstable nucleus emits some particles and changes its constitution, but a stable nucleus always maintains its constitution. Here, figure shows a plot of neutron number versus proton number Z. These black dots represent the stable nucleus, and with white dots represents unstable nuclei. For the graph, we could see that for light stable nuclides ratio n by Z is equal to 1, and n by Z ratio increases for the heavier nuclides. The heaviest stable nuclides ratio is about 1.6. As you saw in the graph, left side of stable nuclides, the nucleus which are unstable nucleus has excess neutrons, whereas on the right side of the stable nuclides, unstable nuclides has excess protons. Friends, our next topic is nuclear radius. We know nucleus are so small that we cannot see them with our naked eyes. So the description of these particles are given by wave functions. Magnitude of wave functions become very small when particles move away from the nucleus. An experiment was conducted by scientists to find the radius of nucleus, and a formula was derived. R is equal to R0 a to the power 1 by 3, where R0 is 1 point into 10 to the power minus 15 meter. Here we represent 10 to the power minus 15 meter as F. So it's become R0 is equal to 1.1 Fm, and we all know A is mass number. When we know the radius of a sphere, so we can find its volume. V is equal to 4 by 3 pi r cube. We know the value of R, so we put it here. Then V becomes 4 by 3 pi r0 cube into A. We know mass of proton and neutron are roughly equal. Let it be m, and mass of nucleus also roughly proportional to the mass of number A. Therefore, m is directly proportional to A. That gives m is equal to small ma. Friends, if we know that we have volume and mass of a substance, we can find its density. So nucleus density is rho is equal to m by v. When we divide mass by volume, we see A is cancelled out. So density of nucleus does not depend on A. Friends, now we will study about nuclear spin. Friends, we know that neutron and proton inside the nucleus move in defined quantum state and have orbital angular momentum. Friends, don't ask me that what is angular momentum, because you have studied in class 9. They also have internal spin angular momentum, and the spin quantum number is ms is plus 1 by 2 or minus 1 by 2. It is sometimes positive and sometimes negative. Therefore, we can say that total angular momentum of a nucleus is called nuclear spin of that nuclides. So friends, if you have understand this topic, then please like my video, and if you are new, then subscribe it. Thank you.